Our final unit in Trig here is dealing with verifying Trig identities, and a couple rules that we're going to get off right off the bat here is that what we're essentially doing is we're going to be proving that different combinations and multiplications and additions of trig functions are equal to some other different combination of functions. And the main thing that we're going to look at is the fact that you can only work on one side of the equal sign. Okay, we're not allowed to use your algebraic type of operations. You can't, add 2 to both sides of an equation like you're solving equations. You are proving and just simplifying one side, and it always makes sense to work on the more complex of the two sides. And you'll see what I mean by that here in a moment. When we're doing these trig identities, there are a bunch of identities that we already know that we just kind of take for granted. A couple of them, and you'll have all of these listed, are reciprocal identities, which, for example, is that we know that sine of theta is the flip of cosecant of theta, is an example of one. Or cotangent is the flip of tangent. Those are a couple examples of reciprocal identities. We also know quotient identities, which the easiest ones there are mainly tangent and cotangent. Tangent is sine divided by cosine. And cotangent, is cosine divided by sine. Those are ones that we already know. The last kind, the real big one, is called the Pythagorean identities. Pythagorean identities. And really there's only one main identity that we use, and that is that sine squared of theta plus cosine squared of theta is equal to 1. That is just an automatic given, one that you need to know, almost like law of sines, almost like SOHCAHTOA. It's something that you will just remember forever in terms of using any sort of trigonometry in your life. So with this main Pythagorean identity, sine squared plus cosine squared equals 1, we can manipulate this equation. We can, for example, subtract cosine from both sides, cosine squared, and get that equation, or subtract sine squared from both sides and get that equation. That's just a manipulation of this same identity. Likewise, if I divided this equation by sine squared everywhere, I would get this equal Pythagorean identity. 1 plus tangent squared equals secant squared. If I divided the original one by cosine squared, I would end up with that equation. Cotangent squared plus 1 equals cosecant squared. And I can manipulate those identities just as much to be able to find different identities. And we're going to use these identities in our next couple of videos to find various ways to simplify these expressions and make equations or these identities prove to be true. We'll use these identities on this slide and that previous slide to find all of those trig identities.